let's get into it. So guys, essentially what we've been speaking about is relationships, how to represent these relationships in different ways, all leading up to just being able to take all of those representations and represent it graphically. Alrighty, so let's have a look at our first example here, and we have got a couple things that we need to do in order to answer this question. So the question is saying to us, write down an equation and then describe the relationship. Okay. Now, in order for us to do this, we can either start with the table if we want, if that's useful for us, but we have a flow diagram here. So what we need to remember is that we have an input value, and remember, input is represented by X, and we have an output value represented by Y. We know that this input value must be multiplied by 10 and then have 15 added to it. So because we know what the rule is here, we can already write down a rule. So in terms of one way to represent this relationship, we can do this with an equation, right? So one type or one way to represent any relationship between two variables is through an equation. So we know that X must be multiplied by 10, so 10X, and we have to add 15 in order for us to get our output value. Now, if you wrote it the other way around and said your output value is equal to 10X plus 15, that's absolutely fine as well. It's completely up to you. All right, but now we've got one way that we can represent this relationship, but we have a different way, or we have a second way that we could represent this relationship, which is through a table. Now, remember, we've got our inputs and our outputs here, and we now need to use the flow diagram or the equation that we've just written in order to determine our outputs. Now, when we are when we're trying to determine outputs, we obviously need inputs. Now, most of the time, we're going to give you an input, and so this first row in the table would be filled in for you. If it's not filled in, remember I've told you before, just pick your values, and that's absolutely fine. So I'm going to give you some values here that I want you to use as your inputs. Right, and what I want you guys to do is I want you guys to give me the output values for these inputs. So I'm just going to give them some numbers here, A, B, C, D, E, F, some numbers here so that on the chat, excuse me, when you give me answers, you can number them for me. All right, so I want you to put your outputs in the chat for me so that we can see what we get, and then we'll chat a little bit more about what's going on. Remember, you can either use the flow diagram that I've given you as the initial part of this question, so this flow diagram over here, or if you are more comfortable with substituting into an equation, which is absolutely fine, you can use the equation that we wrote down. Either one is completely up to you. Both of them will work. Guys, remember, if for whatever reason you can't see the screen, there's two things you need to do. You either need to log out and log back in again, or you need to unpin my screen and then repin it, and that should do the trick. If you're still struggling, let Yolanda or myself know, and then we'll go from there. And guys, remember, sort of the whole point of this section is to explore and to understand different ways to represent relationships. Yes, the topic is called graphs, but there's more than just a graph that we can use to represent a relationship. We've got flow diagrams, we've got equations, we've got tables, and we've got graphs. So you can represent a relationship in many different ways. It doesn't have to be through a graph, it doesn't have to be through a table. There's many ways that we can represent our relationships, and we're exploring all of those. All right, I'm going to give you a few more seconds and then we're going to have a look. Remember, guys, you should be writing this down so that when I do go through the answers, you can literally just tick whether you got it right, do your corrections if you got it wrong, and we can then go from there and deal with any issues you might have. Alrighty, so the first one, if we just use our equation and we apply the fact that x is equal to 1, we are going to substitute in and replace x with 1, and we're going to essentially solve for y. So 10 times 1 is 10, plus 15 gives us an output of 25. We do exactly the same thing when x is equal to 2. We're looking for our output, 10 times 2 plus 15. We know that 10 times 2 is 20 plus 15, and so we get 35. The next one would be 45, 55, 65. Hopefully you're starting to see a pattern there. The next one, not so easy to follow because our input values don't follow on from each other. They're not consecutive like the first 5 were, so we just need to be careful there. But we can use substitution or we can use our flow diagram. 10 times 10 is 100, plus 15 is 115. 10 times 25, 250, plus 15, 265. So those would be the correct outputs for this table. And like I said, hopefully what you saw, especially with the first 5, is that there's a pattern. 25 to 35 is plus 10. 35 to 45 is plus 10. 45 to 55 plus 10. And so hopefully what we're seeing is that there is this pattern with our variables. Remember, we also spoke about the fact that the thing that you're adding each time, so this constant difference, in our rule, in our equation, is actually the coefficient to x, right? So that 10 in front of the x, I don't know why I'm trying to write coefficient, represents our constant difference. And so again, all of these different ways represent the same relationship. They all show some link here, but we have different ways to represent it. Right, does anyone have a question before we have a look at question B? You can raise your hand if you do. You're welcome to put it in the chat if you have a question. It's completely up to you what you prefer. It looked like most of us were getting our inputs and outputs correct, so that's awesome. I want to say Legan, but please correct me if I'm wrong. Are you there? Can you hear us?
Yeah, I think it's probably internet. No, definitely you need to check your earphones or your device. Other than that, you're more than welcome to put it on the chat, okay? But we can't hear you. I think we can move it. Just,
Okay.
yeah,
So,
I can notify us on the chat.
So put it on the chat. Otherwise, we can always try again just now, but double check your audio connection. Right, so guys, you're going to try question B. Oops, sorry. Question B by yourselves. I just want to chat about what is being described here, and then you're going to get a little English, give it a go. B is saying our output number. So remember, this is Y. Oops, let's maybe not be writing in bright red. Oh, golly, Miss Molly. Is found by taking the input number and timesing it by 7. So 7 times x plus 10. So even when we describe something in words or relationship in words, we can still get an equation from that. We can still get or are still able to then find our different outputs or even our different inputs. All right, so really important that we can take words as well, and we can translate those words into a rule or into whatever we may need to use. Okay, so I'm going to fill in the table here for you guys, and I want you to fill it in. Right, so I want you to look very carefully at what values I've given you, because at C, what you're trying to actually find is the input value, not the output value. So just be careful, take a careful look at what I've asked you to do, and let's give these ones a try. Tinswalo, yes, I did see your answer. Thank you very much. It did come through on the chat, so well done. So A, B, C, and D, let's see what we get. Just be careful at C. I'm asking you for the input there. C represents an input, not an output. Nice, grade 8. You're on a roll here. Good, and I'm glad we are trying C, and it looks like for the most part we're getting C correct, which is amazing. Well done. Okay, let's have a look. So guys, again, you have a rule, we can apply this rule. So remember, our rule is y is equal to 7x plus 10. We have an input value. So if I substitute in my input value of 1, I've got 7 times 1, which we know is 7, plus 10, giving me an output value at A of 17. Right, we do the same thing each time. So we've got an input of 3, so 7 times 3 plus 10. 7 times 3 is 21 plus 10, and so we have an output here of 31. Right, I'll come back to C in a second. Let's just have a look at D. So if we have a look at D, this would now be 7 times 11 plus 10, and we know that that is 77 plus 10, which gives us 87. Right, if we now have a look at C, so C is a bit different, and we need to bear that in mind. See, I've given you the y value. So in your equation, y equals 7x plus 10, I have given you what y is. I've told you it's 73, and then we're applying the rule 7x plus 10. So remember, guys, because you've got this equation, you can substitute in and you can solve it like an equation. So that would mean inverse operations mean I have to subtract 10 on both sides, leaving us with 63 equals 7x. And then we know that because of inverse operations, we need to divide both sides by 7. And we get that x is equal to 9. And so this input value here is 9. So remember, we can work backwards from an output to an input as long as we know what operations we're working with and what rules to apply. Alrighty. So any questions, please do ask. What I'm going to do is I'm just going to do that in case you need to take a screenshot of A and of B. I don't think we're going to do C, so don't stress about writing that down in a second. I'm going to have a look and see what our next one is, just because it is a little repetitive, and I would like to draw some graphs today. But any questions, guys, please do raise your hand and ask. Or remember, always on the chat, that's absolutely fine. Nice, good, grade 8s. All right, so we can take a brain break. We're almost halfway. Right, brain break, and then we're going to do some fun graphs. I feel like this has just gone so quickly and we're already almost half past. Well done. All right, so brain break. You know the drill. I want to know the answer of the last equation. I lost a piece of paper, yeah. So this very last equation, I want to know its value. Just take careful note of where things are double, where things are triple, etc., etc. Because we know that that affects what's going on. All right, guys, please remember that when I ask you if you've got questions, it is helpful to try and let me know immediately, not once I've moved on. So just quickly, if we go to D, in terms of how we got 87, so let's just do this quick sticks, otherwise it's going to be quite confusing. This bottom substitution over here is how I got question D. So I know what my input is, it's 11, so I substitute 11 in my equation, so 7 times 11, which gives me 77, and then I've still got the plus 10, so 7 times x, 7 times 11 plus 10. So we end up with 77 plus 10, and that gives me my output of 87. So through substitution, I was able to get my answer of 87. Right, I hope that makes sense. All right, here is our brain break again. Sorry, there we go. Let's have a look, see there. I need to do the brain break as well. I feel like you guys are definitely going to be faster than me, but let's see how we go. If anyone has gotten it right and I don't have an answer yet, I will go back. My brain's having a bit of a brain fart at this moment in time for whatever reason.
I see everyone is just laughing because of the joke. Dear algebra, please stop asking us to find your ex. She's never coming back. And don't ask why. Actually, this is a good one. I'm also putting it on my WhatsApp statuses. It's a pretty good one for algebra.
Okay, I know people have definitely gotten the correct answer. I just want to make sure I get the first person. Teboho, well done. You were so much faster than me. That took me a ridiculous amount of time. So Teboho, if you want to raise your hand to explain it for us, please feel free to, and please do, because we would like to hear from you how you got it. Oh, sorry, Teboho, and then I didn't look at your hand being raised. I'm losing my mind. Right, Teboho, how did you get 104?
Ma'am, the first one is 20 plus 20 plus 20 equals to 60.
Perfect.
The second one, it's one snow globe. Then it's going to be 10.
Good.
10 times 7 plus 10 equals to 80.
Nice.
The lollipop is 9. 9
Good.
times 9 plus 7 equals to be 88. The balloons are 2. It's going to be 14 plus 9 times 10 equals to 104.
Perfect, Teboho, well done.
Thank you.
Right. So guys, exactly like Teboho was explained there, be careful of where there's doubles and where there's only one. So like oh, yo guys, English. So here with our, whatever these are, snow globes, zombies, I don't know. The double is 20, so only one is 10. With the balloon things, one pair is 7, so a double pair is 14. So remember with these, where you get caught out, and I've been caught out by this, you've watched me get caught out by this, is where we don't see the doubles. So always just bear in mind where your doubles are to take it into account. Now, Teboho, and I know that there were lots of you who got 104 as well. I was just incredibly slow tonight, so well done to all of you as well. I don't know if you want screenshots of this. I'll leave it up for a second or two. And then we're going to carry on with some more examples. Since while I'm certainly not this funny, I can guarantee you that all of my jokes come off the internet. So thank you, people who are that funny. And yes, I was not well, but we're getting there. All right, guys, nice, well done. That was very quick. All right, so like I was saying earlier, a really important skill that you need to have, especially as you start to move up in maths, is being able to put this relationship into an equation. Now, what we're going to start to see is that equations and graphs go hand in hand. If you want to draw a graph, 9 times out of 10, we need to have an equation first in order to get the graph. So being able to write an equation, very, very important. All right, so what we're going to do is we're going to read these and we're going to try and come up with an equation. So I'm just going to start with the first one. The output value is the input value plus 4. Okay, so what I like to do, because sometimes for whatever reason, the second we start putting words in maths, we just get so overwhelmed and so confused. It's like a word problem. For whatever reason, we panic when there's a word problem, and there's no need to. So what this is saying is that our output value, which we know is y, is the input value plus 4. Okay, so all I've done is I've taken my words and I've translated it into maths. That's essentially what maths is. It's a language. Now we know the output value is the answer we want. So the answer we want is found by saying x plus 4. And literally just by taking the English and translating it to maths, we're able to get our equation. So guys, please, I don't want you to feel scared of words in maths. I know that we feel like there's no place for words in maths, but there is. And reading with understanding is really important. Okay, so I'm going to read the second one. Weird noise. I'm going to read the second one, and then I want you to try and give me an equation there. So B says the sum of the input value and 5 is multiplied by 3. So the sum of the input value and 5 is multiplied by 3. So let's see if we can come up with an equation here. If it's going to make you feel better, you can say is multiplied by 3 to get the output. If you would like to add that in for yourselves, absolutely fine if you would. So I'm going to read it one more time. The sum of the input value and 5 is multiplied by 3 to get the output value. So let's try that one by ourselves. Okay, we've got a couple coming up, so let's see. The input value, which we know is x, and 5, and importantly, it's the sum of the input value and 5, so x plus 5 is multiplied by 3. So what that means is that this whole sum, that whole thing, is then multiplied by 3. Now we know that we can write that a bit neater to say that our output value is equal to 3 times the sum of x plus 5. Now guys, if you wanted to, you could distribute this. There's nothing wrong with doing that. So if you would rather say y is equal to, and then multiply the 3 in to get 3x plus 15, that's absolutely fine. But our equation essentially needs to be one of these two. The sum of x plus 5 being multiplied by 3. Now, please remember that an exponent of 3 is not the same thing. So if we had y is equal to x plus 5 to the power of 3, we're saying that we're multiplying this bracket 3 times. And that's not what we're doing. We're not multiplying it 3 times. We're multiplying it by 3. So again, really important to read our question carefully and make sure that we are understanding what's being said to us. All right, so for question B, you've got 2 options. I don't particularly mind if you choose to simplify or not. It doesn't really matter. They're the same thing. Either y equals 3 times x plus 5. Guys, I'm not on C yet. Can we just hang on? Because what you're now doing is you're putting answers on the chat, and not only are you now confusing me, because now I'm worried that some of you are doing the wrong thing for B, but you're also now confusing other people. So just hang on. We're going to get to C. Don't stress. Let's just hold off on putting our answers there until I've asked you to do that. All right. Okay. So for B, there are 2 options, either the non-simplified or the simplified version. It doesn't matter what you write down. What is important is that you're taking a bracket and you're multiplying it by 3. Okay, we're not just multiplying the x by 3, nor are we just multiplying the 5 by 3. It needs to be both of them together. Right, so now if we have a look at C, we've got the input value is multiplied by 3 and then has 2 subtracted. Again, if you want to add in, get the output value, that is fine too. Now, please, if we can put our potential answers on the chat, that would be wonderful. And then we'll have a look in a minute, 60 seconds. Right, it looks like we got it, so well done. So again, input value we know is x is multiplied by 3, so that gives us 3x, and then we have 2 subtracted from that product. So our rule here would be y is equal to 3x minus 2. So again, guys, read with understanding, and if you aren't feeling super confident, do exactly what I've done in each case. What I mean by that is break it up. So on top, I wrote the sum of the input and 5, and I wrote that as an expression. Then I went on to deal with the multiplied by 3. In this one, I dealt with the input value times 3 to get my 3x, and then I dealt with my subtract 2 by minusing 2. If you break it up, 9 times out of 10, you're going to get the equation. It might not look beautiful, but you're going to get the equation perfectly. Alrighty, so take your screenshots of those 3. No, let's not do that yet, because apparently there's a 4th one that I forgot about. Right, so let's try D. The output value is the input value squared. So let's write an equation for D. The output value is the input value squared. Think about what squared means. And let's write an equation. Nice, guys, well done. So I'm really glad that we're starting to see the difference between squared and times 2. It is something that we do mix up a little bit, but there are 2 different things. So just bear it in mind. So the output value is the input value to the power of 2. Very, very nicely done. So guys, just remember, and like, I'm not going to stress about it on the chat now because I'm assuming you mean what I mean. just remember, if you ever want to type out to show that it's an exponent, you use the little like hat thing, which you would say shift 6 to get. So shift, and then you push the number 6, and you get the little hat, and then you would put the number that the exponent is. So you would type x, shift 6, and then 2, and that shows you that you have an exponent of 2 to the x. Right, so just a silly thing.
Yeah, the little puppy.
Exactly. Yeah, so like I said, not a huge thing, but just for future, if you ever want to type it, that is how you do it. You also get like very fancy programs that you can make exponents and stuff, which whatever. Right, nice. So let's take our screenshots here, grade 8. And then if anyone has any questions, now's the time to raise your hand and ask me. Otherwise, we're gonna start drawing some graphs, which is very exciting. I love graphs. It's one of my favorite sections in maths, even up to matric, love it. It links so many sections. It shows us so like visually relationships and stuff. Oh, it's just such a nice one. When we square the number, is it only the 2 on the top? Yes, because that 2 is showing that we are squaring the x. So this exponent, this 2, is representing the squared, and it's only the 2 on the top there. Right, I did see a hand, but it seems to have disappeared, so I'm hoping we're okay. And Swallow, I'm glad to hear we like graphs as well. And guys, I said this to you at the start of the section as well. Even if you decide you're going to do maths lit from grade 10, graphs is a really important part of maths lit as well. So regardless of what subject you do, it's going to be important. Don't we also... Mission, ma'am, don't we get the 3 also? Okay, I think I might have maybe misunderstood something. So guys, your exponent can be any number. The phrase squared means 2. If it had been the input value cubed, then your exponent would be 3. If it had been the input value to the power of 8, then your exponent would be 8. So the exponent's number can change, but the squared means 2. I think maybe I misunderstood something, so I'm sorry. I hope that makes sense. And just if we still aren't 100% sure, let me know. Cool, Gabriella. Awesome. Yeah, sorry. I think I just misread and I misunderstood. So I apologize, guys. It happens to the best of us. Sometimes in my brain, I think I know what you're saying, and then I make an assumption, which is never the right thing to do. Alrighty, so guys, let's get into this graph stuff. Love it. Right, so it looks a bit blank because we are going to chat about this first one together, and then we will see where we're at. I just want to move this over because obviously I make my life hard by not putting everything together, you know. All right. Okay, so whenever we draw a graph, it's going to be on a Cartesian plane. Now, someone did ask me earlier, but we have done Cartesian planes already. I'm 90% sure it was in term 2. But again, if you just go check on the website, all the topics are labeled. And so you should see exactly where we got or where we did the Cartesian plane. Right, again, guys, please let's take screenshots when I ask you to. So just quickly again, there are the screenshots of the equations we've just done. And then let's have a look. All right, so when you're drawing a graph, like I've said to you already, an equation is a very useful thing. Now, pretty much from this point, we're always going to give you an equation in order for you to draw a graph. It might be a case of we give you some words, ask you to do the equation, and then ask you to get a graph. It might be a case of we give you a pattern, ask you to find the rule, and then draw a graph. But an equation is really useful to you. So we're going to have a look at a nice, easy one to start off with. It would help if I had a pen here. Our equation is y is equal to 2x plus 1. Now, Another really useful representation of a relationship for graphs is a table. You're going to learn as you go on in maths. Every time we ask you to draw a graph, your teachers will say to you, when in doubt, draw a table for yourself, all right? There is no reason why you can't help yourself, so just draw a table, get it right first time round, and then you're sorted. All right, now remember guys, if you are going to make your own table, so draw your own table, you have to then pick your input and output values. You can pick any values you want, but let's just quickly jump to our Cartesian plane and remind ourselves of what the Cartesian plane is. So your Cartesian plane is an X and a Y axis. And remember, there's numbers on this Cartesian plane. So this would be 1, 2, 3, etc., etc. These axes, the X and the Y axis, are basically like number lines. They form this sort of cross, and they are two sets of number lines that we are working on in order to plot certain points. All right, your Y axis in the upwards direction is positive, and in the downwards direction, negative. All right, so we are essentially wanting to plot a graph, remember in the middle here, that is our 0 point, our origin. So we want to now take this relationship of 2x plus 1, and we now want to transfer it onto our Cartesian plane and represent it visually. All right, so what we need to do is we now need to pick some input values. Now, guys, my advice to you is pick a negative x value, pick 0, and pick a positive x value. Just because then you're going from negative all the way to positive and you're getting a range of values. My advice would always be pick something like -3, 0, and let's go 4. So a negative, 0, and positive. It doesn't matter what values you work with your input value. Remember, you can pick any input value because you are going to correctly apply your rule in order to get your output values. Just going to make a note here. You can pick any values. Hint, pick a negative, 0, and a positive. That will just help you get a really clear picture of what the relationship is. All right, so what we now want to do is we want to take these input values that we've just got and we want to apply the rule in order to get our output value. So I'm going to give you 60 seconds, so 1 minute. I want those 3 output values for -3, 0, and 4.
Let's go, my people. We can do this.
Good. So just remember, you're just substituting in. All you're doing is substituting in order to find your outputs. Lessing, if you want it to be -1, 0, 1, you can. If those are your inputs that you want to choose, that's fine. I've chosen those inputs. As I've just said, you can pick any x values. It makes no difference whatsoever. As long as you apply the rule correctly, whatever you want. So these are the ones I've picked, but yes, if that's what you want to pick, go for it. Okay, so guys, just that we're clear, we will substitute in. So 2 times -3 plus 1. Positive times a negative is a negative. 2 times 3 is 6 plus 1. And that gives us -5. So our first output, -5. We'll do exactly the same thing with 0. So y is equal to 2 times 0 plus 1. We know 2 times 0 is 0, and 0 plus 1 is 1. So that's our second output. And then when we get to the third, we will have y is equal to 2 times 4 plus 1, which is 8 plus 1, which gives us 9. And so that's our next output. All right, so now that we've got these, we have got some coordinates that we can go and plot. As I'm doing this, I've obviously not done my axes big enough because you know how I am. Yeah. Technology is amazing. You can just move things at your will. Alrighty, so what we now have and what we need to now go back and remember about our Cartesian plane is that we have coordinate pairs. So remember, on a Cartesian plane, what you want to do is you want to plot coordinates, and these pairs here are your coordinates. So our first coordinate would be -3, -5. Our second pair, 0, 1. And our third pair, 4, 9. Remember, a coordinate is always the x value first and then the y. We go alphabetically. It is never the other way around, always x, y. So now we can plot these coordinates. So if we plot the first one, -3, 5, -3, -5, sorry. Remember that what we do is we start with the x value. We plot where that x value would be. Sorry, again, have not left myself enough room because, you know. So here I am at -3 on x. Here is -5. And essentially what we do is we plot two lines, and where those lines join, we draw a point. Now, guys, I would not draw in those dotted lines. Just use a ruler or just use a ruler and go from there. But essentially where they meet, that's where we plot our point. All right, so our first point that we have here is -3, -5. I'm just going to add a label so that we know that that's the point. Right, the next one, 0, 1. So 0 is x, and we go up to 1 on y. So there's 0, 1. And the next one, 4, 9. So we go to 4 on x, and we go all the way up to 9 on y. Right, and hopefully what you see is that if you sort of follow where these points go, what we have is a graph. Now we can join these points in order to form that graph. So if we now go and join those points, we join it with a ruler and a straight line. There is my graph of y is equal to 2x plus 1. Now you don't have to write what I've just written down here on your graph. I'm just showing you that the straight line represents that relationship. Okay, and so the second we've got our input and our output pairs, we can now go and plot our graph and represent our relationship. Now, guys, graphs can take on many different forms. This is a straight line, and we'll chat about more types of graphs and why they are different shapes as we go along. But this is essentially another way, and a way that we need to now start getting very comfortable with, of representing a relationship. Simtanda, you can get graph paper if you want. Otherwise, you just draw the Cartesian plane. In an assessment, so in a test or in an exam or whatever, we usually do give you graph paper. So usually we give it to you, and we don't expect you to draw the graph paper yourself, but you can also just draw it yourself. What I would suggest you do is you just use your ruler, and every centimeter, that's your tick mark along your axes. So you definitely can just do it yourself. But usually we do give you graph paper in your test and in your exam. Right, so guys, if anyone has any questions, now is the time to raise your hand and ask me. Lindo?
Hi,
Nope.
ma'am.
Yes, okay, yeah.
Ma'am, sorry, but can I ask, when do you think we're going to start learning about Pythagoras as well as probabilities?
So if you have a look at what I always put up at the start of every lesson, I let you know what's happening. So Pythagoras is the next topic coming up. Probability, which for whatever reason, probability is not here. We will do probability though in the boot camps, and maybe that term for revision, I'll do some probability as well, but it's all there at the start.
Thank you, ma'am.
Sure. Kenya? Are you there? Can you hear us? Yolanda, can you hear anything?
On my side, I couldn't hear anything.
Okay.
Yeah, you can put your question on the chat also. Let me just put also this for the quiz because I see the time is.
Okay, so guys, just quickly, there was a question of I don't understand the working out. All we're doing here to get these values is we're taking the X value, so the input value, and we're replacing it in the equation. So this first one, we replace the X with the -3, and we solve to get our output. We do exactly the same thing with all of our inputs. So for the next input of 0, all I did was I replaced the X with 0, and I got the output. Right, so it's through substitution that I'm getting my answers.